Welcome to the channel CSAITTL. Today, we are starting at ground zero, day one on a single server. You've got 10,000 users, your PostgreSQL instance is cruising, and life is good. It's awesome. But notice that single path. That's your baseline. Everything we discuss from here on out is a reaction to that simple path becoming a bottleneck. Before we dive in, please like, subscribe, and share this video to help us keep these deep dives coming. And also, head over to our www.bitbytalker.com to find a complete library of system design guides covering software data, AI, and machine learning engineering. This is what it looks like, bitbytoken.com. We have different components here. So please do check out this site and share your feedback so that we can make it even better. Okay, let's get into the architecture then. You can fix what you haven't felt. When you hit 500 million rows, you're going to experience the meltdown. Write contention where millions of inserts block each other. Backup that takes 8 hours to finish. And analytics queries that bring your production traffic to its knees. This is the hard ceiling. It's painful. But at the moment, you stop being a developer and start being an architect. First, we look at partitioning. Think of it as a reorganizing a filing cabinet. You aren't adding new space. You're just dividing one logical table into internal physical segments. The best part of your interview? The application code doesn't change. It still runs select star from users. The database engine uses partition pruning to skip irrelevant segments, giving you a 10x reduction in I/O for free. But how do you decide to split that data? You have two main deterministic paths. Range logic. Um, you have two main range logic is great when you have time series data, but beware for the hot partition. New traffic always slams the latest tier. Hash logic uses modular path for even distribution, but it kills your ability to run efficient range queries because the data is non-contiguous now. Every choice has a cost. Then there is a semantic mapping. List partitioning lets you group by human readable categories, like separating US and EU data to handle GDPR compliance. You can even use composite partitioning, where you nest strategies like partitioning by year, then subpartitioning by user ID. The key is to match the strategy to your dominant query predicate, not just pick the column that you look nice. Here is the ceiling of partitioning. It scales reads, but it does not scale writes. You're still bound by the same hardware write capacity and same shared memory and the same single point of failure. If the box crashes, everything goes down with it. When you hit the wall, you have outgrown internal organization. It's time to build branch libraries across the network. Welcome to the Sharding Grid. This is a true horizontal scale. You're spreading data across multiple, completely independent database instances. Each shard has its own CPU, RAM, and disk. N server equals n times the write capacity. The catch? It's no longer the database jobs to route these requests. It's an application level concern. Your middleware now has to calculate exactly which shard holds the data. When designing your routing, avoid the resharing catastrophe. If you use simple modulo hashing like user ID modulo 3 and add a fourth shard, nearly 75% of your data has to migrate. That will cause a massive production outage. Whatever you do, do not propose this in an interview for a growing system. It's a recipe for disaster. What about range partitioning or range sharding, sorry. It seems intuitive, assigning IDs 1 to 50 million to one shard, 50 to 100 million to another. But this creates a right hotspot. All your new registrations are flooding into the 150 million plus shard, making it a single point of failure. The older shards just sit there, idle, underutilized. It's simple, but it doesn't scale for active growth. The industry standard is consistent hashing. By mapping your shards and your users into a virtual ring, you ensure that any given user belongs to the nearest clockwise shard. This is the magic behind DynamoDB and Cassandra. If you move from 3 shards to 4, only about 25% of the data needs to move. It's a dominant approach for a reason. For a real world masterclass, look at how Instagram handles it. They use schema namespacing, I can speak today. They use schema namespacing combined with an ID generator. By encoding the logical shard ID into the top bits of the user ID, the data becomes self-routing. You completely eliminate the network round trip to a routing service because the ID tells you exactly where to go. That is first principles engineering. If your scale is truly massive, you don't want to manage this complexity in your own app code. You adopt infrastructure like Vitess, a proxy that abstracts the shard management. The application thinks it's talking to one database, while Vitess handles the reality of hundreds. Used by GitHub, Slack, and Square, the lesson is clear. If the complexity gets too high, buy or adopt specialized infrastructure. Don't build it yourself. So the showdown, partitioning versus sharding. Partitioning is internal, low complexity and easy for joins, but it doesn't scale writes. Sharding is external, high complexity and breaks cross-shard joins, but it gives you the true horizontal write capacity and isolated failures. Knowing when to trade one for another is a core skill of a senior architect. Always follow the scale decision tree. Tier 1, optimize your indexes. Tier 2, partition the table when you outgrow those indexes. Tier 3, only shard when you have hit the physical write ceiling of your hardware. Don't jump straight to sharding. It adds massive operational overhead. The best system often do both. They shard for horizontal scale and then range partition within each shard for internal performance. To wrap up, here is your mental cheat sheet. 10 million rows, 500 million rows, partition it. 2 billion rows and global, consistent hashing. Know the constraints, know the trade-offs, and you'll walk into the interview with total confidence. What's the most complex scaling challenge you have ever faced? Let us know in the comments below. If you found this session valuable, please like, share, and subscribe, and I'll see you in the next one.